Today we're going to start day 3, but we're only going to do part 1 for unit 1 of trig. So we're going to define 6 trig functions, and if you remember last year we had 3, so we're going to double that this year, and we're going to find the values of those trig ratios or functions using special triangles. So this is non-calculator work, and please take note that on quizzes and tests you won't be doing these with your calculator. You have to know your special triangles. All right, so isosceles right triangle is a 45, 45, 90. I know we had this last year, so hopefully this will refresh your memory. The only difference is now we're kind of looking at it on the coordinate plane. So you'll see here we have our 45, 45, 90 triangle. The hypotenuse is always across from your right angle. And remember, we're still talking about angles in standard position. So this is still our initial side and this is still our terminal side. So our angle that we're talking about is this 45-degree angle. And we're going to define our trig functions off that angle that is created by our our initial and our terminal side. So if this is our angle, if you remember from last year, our adjacent side is the side, our adjacent side is the side that is connected to the angle, but not the hypotenuse. So that's going to be our adjacent side. Our opposite side is the side across from the angle. So in this case, this is our opposite side, and our hypotenuse, of course, is the side that is across from the 90-degree angle. So if we drew a triangle with a side length of 1, and since it's isosceles, you're going to notice that the length of this side and this side are both 1. If we did the Pythagorean theorem, you would see that the hypotenuse is going to be the square root of 2. And then one other note, if we're looking at this on the coordinate plane, this point here has a coordinates, x coordinate of 1 and y coordinate of 1. And that's going to come into play later. So that's the layout of a 45, 45, 90 on our trig coordinate plane. It has 2 side lengths. The length of the legs are 1, and the length of hypotenuse is square root of 2. And if you I know in my class we did a little table, a square root of 2, which showed us the ratio of sides for our 45, 45, 90 degree triangle. The other thing to remember from last year is SOHCAHTOA. So this tells us our ratio of sides. So for our regular trig functions that we learned about last year, the sine is the opposite, and I'm sorry, for some reason it doesn't show these lines very well, so I'm going to draw them in. So our sine is our opposite over our hypotenuse. Our cosine is our adjacent over hypotenuse, and these are the lengths of the sides that we're talking about. And then our tangent is our opposite over our adjacent. So we learned those last year, and that's what SOHCAHTOA was. This year we've got a couple of extra functions. They're called the reciprocal functions. Why? Because they are the reciprocal of our regular functions. So cosecant is the reciprocal of sine. What does that mean? It means I'm going to flip over the ratio first of the sine, which is opposite over hypotenuse, and it becomes hypotenuse over opposite. So cosecant is just the opposite, or the hypotenuse over the opposite. You can also think of it as 1 over sine. And you're going to have to think of it that way when we eventually get to doing things on the calculator. All right, so secant then is the reciprocal of cosine, meaning it's going to be hypotenuse over adjacent. Cotangent is the reciprocal of tangent, so it's going to be adjacent over adjacent over opposite, sorry. And again, you can think of this as 1 over cosine, and this one is 1 over tangent. But most of the time, you're just going to want to think of it as these ratio of sides flipped over. So given that, let me clear all the markings off. So if these are our side lengths, adjacent, opposite, and hypotenuse, we can use those ratios to find our values. So sine of 45, so the sine of this angle is the opposite over the hypotenuse, which is going to be 1 over the square root of 2. And we're going to rationalize it. We're going to multiply 1 over the square root of 2 times the square root of 2 over the square root of 2 to give us the square root of 2 over 2. So we continue to rationalize things in this unit. Cosine adjacent over hypotenuse ends up being exactly the same thing as sine. Tangent opposite over adjacent, which is 1 over 1 or 1. And now we're going to find our reciprocal functions. Cosecant is hypotenuse over adjacent or opposite, which is going to be the square root of 2 over 1, which simplifies to just the square root of 2. Secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent, square root of 2. And cotangent is adjacent over opposite, which is 1. So you need to know your special triangles, and you need to know your ratio of sides. And from that, you're going to figure out your trig ratios. All right, if you remember, we also had 30, 60, 90 degree triangles. And we have those again this year, but we're going to have, basically we need to have, oops, I don't know what happened to my revealer. Basically we need to have them in 2 orientations. Because remember, we're only looking at this angle. And actually, I meant to start with this one. Whoops, I think I skipped. Here, 30, 60, 90. So this is the 30, 60, 90, and that means that the 30 degree angle is here. So it matters this year where the 30 degree angle is. And if you remember from last year, if you have a 30 degree angle, so it's 30, 60, 90, our ratio of sides is b times the square root of 3, 2b. So if our side opposite 30 degree angle is 1, that side opposite the 60 is going to be 1 times the square root of 3, which is just the square root of 3, and the side opposite 90 is just 2. So we're going to use those side lengths, and again our adjacent and opposite are the same. This is adjacent to our 30 degree angle, this is opposite, and obviously this is our hypotenuse. Our ratio of sides is over there, so if we wanted to find the ratio side or the trig ratios for a 30, 60, 90 triangle, meaning that it's all with respect to that angle there, which is 30. Sine is opposite over hypotenuse, so it's going to be 1 over 2. Adjacent or cosine of 30 is adjacent over hypotenuse, which again we're going to rationalize, so it's going to be adjacent. Actually, we don't have to rationalize that. Adjacent is just the square root of 3 over the hypotenuse, which is 2. The tangent is the one we have to rationalize. So we've got opposite, which is 1, adjacent, which is the square root of 3. And remember, multiply top and bottom by the square root of 3 to get the square root of 3 over 3. And this is the way in the book, anywhere you look online, if you looked up tangent of 30, you're going to see it written this way, not this way. So you have to rationalize. Cosecant is hypotenuse over opposite, so it's going to be 2 over 1, which is 2. This is hypotenuse over adjacent, which is 2 over the square root of 3. Gets rationalized to 2 the square root of 3 over 3. So just in case, just in case we're a little unsure how we got that, multiply top and bottom by the square root of 3. This just stays as 2 times the square root of 3 over 3. And then lastly, cotangent adjacent over opposite, square root of 3 over 1, which is just the square root of 3. So again, you have to know your special right triangles, the ratio of sides, as well as the ratios for your trig functions to be able to find the answers to these. You will have to know these for your test. I'm not going to give you the special triangles. I'm not going to give you the ratio of sides, and you won't have really any help for this. So please make sure you know these. All right, and then we have 60, 30, 90, which is exactly the same as a 30, 60, 90, but notice the difference. Our angle, 60 degree angle, is here because our trig functions are based off of this angle that has the vertex at the origin. So the only thing that's really changed is now our adjacent side is going to be 1 and our opposite side is going to be the square root of 3. So you'll see the same values, but they're going to be in different spots. So opposite over hypotenuse is the square root of 3 over 2. Adjacent over hypotenuse is 1/2. Tangent opposite over adjacent, square root of 3. Cosecant is going to be 2 over the square root of 3, which is 2 square root of 3 over 3. Secant is hypotenuse over adjacent, which is going to be 2. and cotangent is adjacent over hypotenuse, which ends up being this. So those are the special triangles that we need to know. We need to know a couple more things in order to fill out the trig sheet, and the trig sheet is the thing you're going to get next time, because it turns out we can make these special triangles in all four quadrants to cover our angles. So if you'll notice, the ones that we've drawn in the last few slides have been in quadrant 1. But we can also draw a 60, 30, 90 triangle in quadrant 2 and find ratios from that, but the angle is going to be different. So that's what I want to talk about next. How do we find the cosine of 120? So you could put it in your calculators, but that's not how we're going to do it, because it turns out we can use a special right triangle to find the cosine of 120. What do we have to do? First thing we want to do is find our reference angle. So remember, we're going to subtract 120 from 180. Our reference angle is 60. This tells us which special triangle we want. We want the one with 60 in not really necessarily standard position, but we want 60 to be the angle defined by the origin. And then we want to find out what quadrant 60 is in. It's in quadrant 2. So that means we're going to draw a 60, 30, 90 degree triangle in quadrant 2, and here it is. So you can see here's our 60 degree angle. The only difference, so you're probably wondering why we even have to draw it in quadrant 2, because we have to take into account the sign of the x and y coordinates in that quadrant. Notice quadrant 2, this is the negative part of the x-axis. So this is going to be, even though the actual length is 1, we're kind of looking at our coordinates. If we looked at this coordinate, it would be -1 square root of 3. So we have to use -1 as our adjacent side length, because that kind of gives us the direction and the quadrant that tells us where we are in the coordinate plane. So this is kind of one time where length can be negative, because we're defining it as length, but it's really the coordinate that we're interested in. So adjacent is negative, and then opposite is going to be positive, because this, in fact, is positive y still. So if we looked at the cosine, here's our triangle. It's going to be adjacent over hypotenuse, just like that doesn't change at all. So if we look at our adjacent length, it is -1, and our hypotenuse is 2. So this is a little hard to see. The actual answer is going to be -1/2. Very similar to a just 60 degree triangle, except instead of being a +1/2, it's a -1/2. So the next thing we're going to do is to take into account the quadrants of the various angles. So it says the only change in the ratio will be the sign of the ratio. So no matter what quadrant you have, once you find the reference angle, which is going to tell you which triangle to use, you're going to get the same ratio of sides as you did, as we saw in the first 3 slides, but the sign could change. It doesn't always. So you're going to find out later 2 quadrants are positive and 2 quadrants are negative. The sign of the adjacent side is determined by the sign of the x coordinate. So adjacent basically corresponds to x coordinate. The sign of the opposite is determined by the coordinate of the sign. It should be sign, not side. The sign of the y coordinate. And please note, hypotenuse is always positive. Why? Because how do we get hypotenuse? We square the adjacent, we square the opposite, add them, and take the square root. We use Pythagorean theorem. You're never going to have a negative, because you can't take a square root of a negative number. And this is a summary. So what are going to be your signs of your x and y coordinate, which defines your sign of your adjacent and opposite side? So adjacent and opposite are both positive, and I'm having spelling problems here. This should be opposite. some fixes. Sorry, this is a new. So they're both positive in quadrant 1. In quadrant 2, our x is negative, so our adjacent's negative, and our y is positive, so our opposite's going to be positive. Notice in the third quadrant, we're here at the negative y and negative x, so both our adjacent and our opposite, or x and y coordinates, are negative. And finally, in our fourth quadrant, our adjacent, we're back here at positive x, so our adjacent, or x coordinate, is positive, and our y coordinate is going to be negative. So this should help you have an idea of what your opposite and adjacent signs are, and therefore what your trig ratios, what the signs of your trig ratios should be. Notice in quadrant 3, your tangent and cotangent will be positive because you'll have a negative over a negative. So that's something to keep in mind. It's a problem, mistake I see a lot of times is students forget that. So you will have a reference angle and special triangle worksheet to fill out this tonight, and then next time we'll go after part 2, you will fill out the full trig sheet. Bring questions to class.